Welcome to Peaceful Sleep 101. Have you ever wondered, how does our brain move to sleep at night? Every night, as the world quiets down and our eyes grow heavy, something truly magical happens inside our brains. Without us even noticing, millions of tiny cells begin a graceful dance, a transition from wakefulness to rest. Tonight, we'll explore how your brain gently guides you into sleep step by step, wave by wave. So find a comfortable place, let your body relax, and allow your mind to drift as we uncover the quiet science of falling asleep. First, the shift from wakefulness. When you're awake, your brain hums with fast, energetic rhythms called beta waves. These waves reflect alertness, the mental state you're in when solving problems, scrolling through your phone, or talking with friends. As evening comes and light begins to fade, your eyes send a signal to a small region deep in your brain, the suprachiasmatic nucleus, or SCN. This tiny cluster of cells, often called your biological clock, is what keeps track of time inside your body. When it senses darkness, it whispers to the pineal gland, telling it to release melatonin, the hormone of sleep. Melatonin doesn't force you to sleep. Instead, it gently invites your brain to slow down, like dimming the lights before a concert begins. As melatonin rises, beta waves begin to fade, and alpha waves start to take over. These slower rhythms appear when you close your eyes and let your thoughts wander. You might start to see faint mental images, remember snippets of your day, or feel yourself drifting somewhere between thinking and dreaming. Second, the edge of sleep, the hypnagogic state. At this point, you enter what scientists call the hypnagogic state, the twilight zone between wakefulness and sleep. It's a delicate bridge, lasting only a few minutes, yet filled with strange and beautiful sensations. You might feel as if you're falling, floating, or hearing your name called in the distance. Your muscles may twitch, a sudden hypnic jerk, as your brain begins letting go of conscious control. Inside your head, neurons start to synchronize. Instead of firing rapidly and randomly, as they do during the day, they begin to pulse together in slow, rhythmic patterns, theta waves. Theta waves are the first true sign that the brain is surrendering to sleep. They appear mainly in the hippocampus and neocortex, regions responsible for memory and awareness. During this time, your brain is actually preparing to store and organize the day's experiences. Imagine it like a librarian, quietly closing the books of your waking life, tucking each one onto the right shelf before dimming the lights of the library. Third, stage 1 and stage 2 sleep. The first official stage of sleep is called stage 1. It lasts only 5 to 10 minutes, a gentle glide downward. Your heartbeat slows, your breathing becomes steady, and your body temperature drops slightly. Then comes stage 2, where you'll spend nearly half of your night. Here, your brain displays two fascinating electrical patterns: sleep spindles and K complexes. Sleep spindles are quick bursts of activity, like tiny sparks that help shield your mind from outside noise. They protect your fragile rest from being disturbed by a sound, a movement, or a passing thought. K-complexes, on the other hand, are large waves that act like a mental gatekeeper. They help your brain decide what's important, filtering external stimuli so you can stay asleep even if a door creaks or a car passes by outside. Together, spindles and K-complexes form a beautiful symphony of stability, helping your brain settle deeper into rest while your body continues to relax. Fourth, deep sleep, the silent healer. Eventually, you slip into stage 3, also known as slow wave sleep or deep sleep. This is where your brain waves become long and slow, the delta waves. In deep sleep, your brain is at its quietest. It's as though someone turned the lights low and closed the door to the outside world. But inside, a powerful restoration process is underway. Your body releases growth hormone, repairing tissues and muscles. Your immune system strengthens, clearing out toxins and inflammation. Even your brain cleans itself. The glymphatic system flushes away metabolic waste, including beta amyloid, the same protein linked to Alzheimer's disease. Deep sleep is the time when the body heals, the brain refreshes, and your memories begin to solidify. It's your mind's nightly renewal, a soft reset button preparing you for a new day. Fifth, REM sleep, the dreamer's realm. After deep sleep, your brain begins to stir once again, entering REM sleep, the stage of vivid dreams. REM stands for rapid eye movement, named after the fluttering of your eyes beneath closed lids. During REM, your brain waves resemble those of wakefulness, yet your body remains almost completely still. This is due to REM atonia, a protective mechanism that prevents you from acting out your dreams. It's during this phase that the brain integrates emotions, solves creative problems, and connects distant ideas. Dreams may appear chaotic or surreal, but beneath the imagery, your brain is processing your experiences, turning them into emotional understanding. In a sense, REM is your brain's nightly rehearsal, preparing you to handle life more gracefully when you wake. And then, as the night cycles between deep sleep and dreams, your brain continues this gentle rhythm, about every 90 minutes, until dawn softly arrives. When morning light touches your eyelids, your melatonin levels fade, cortisol rises, and beta waves return, lifting you gently back into wakefulness. Every night, your brain performs this quiet miracle, not with force, but with elegance and balance, a delicate choreography between chemistry and rhythm, between stillness and renewal. So the next time you close your eyes, remember this. Your brain knows exactly what to do. It's been practicing this art for millions of years. The ancient, graceful transition into sleep. Thank you for joining me tonight. I wish you the best. Sweet dream.